and welcome to this week's episode of Automated. I, of course, am Stefan Salz-Oxmacher, your host, and sitting across from me is Paul Atreides, not quite in full warm form yet. And sir, what is the mind killer?
I think it's the cold that you brought around and infected everybody with and still are nursing.
Yeah, my son gave me a cold 2 weeks ago. I refused to stop working, which means I've infected about a third of the team, and I'm still sick 2 weeks in. So, this is leadership by anti-example.
Yeah, currently our office, Thanksgiving notwithstanding, is like half empty with people who are feeling ill. So great work, CEO.
Whoops. Anyway, so this, of course, is Automated, our weekly podcast that we never miss, where we talk about robots, fun things with them, challenges with them. We make up a couple of robots along the way. I, of course, am Stefan Salz-Oxmacher, CEO and co-founder of Polymath Robotics.
So nice, you had to say it twice.
Yep. Well, I didn't say the Polymath Robotics part before. This is a sponsored podcast.
Sponsored by ourselves?
Yes. Yeah, I mean, one hand
counts.
feeds the other. This is...
You're mixed metaphors, man.
We mark it as a loss in one column and profit in another, and eventually we become Enron.
Oh, I was going to say, and eventually you become NVIDIA, because that's apparently a big chunk of their current business strategy.
Our revenue is going sky high from all the companies we invest credits in.
Yeah. We'll get investment that way. That's right.
So, Ilya, what are we going to talk about this week?
This week, we're going to talk about the intersection of engineering and business and how that can go sometimes right and sometimes wrong.
And how, there's a lot of bad business in robotics. And along the way, we'll also talk about a recent blog post I threw together, differentiating between what I generously call hype robots, and I think the other word I used was practical robots or reasonable robots, with more than a little bit of bias in between the two. So with that, let's play our game. So this is our game, which we do in our first section of each podcast. Essentially, we draw cards for a technology we have to use and a market that we have to use it in. Ilya, during one, I think, sales call that he was bored, coded this up into a little web bot. He had ChatGPT add a bunch of really lame technologies in the industry, so I just replaced a bunch of them. So I have one on mine, but Ilya's making excited faces and gestures that he likes his combination more.
Applying USVs to waste management and recycling.
Terrific.
Right?
This is fantastic.
This is the right one.
Yes. I'm very yes. Okay. Terrific. So I think this is a space that has most thoroughly been vetted in outer space. I, of course, am talking about the robots in the waste recycling bin on the Death Star, where, of course, spoiler alert for a movie that came out in 1978, Luke and Han and Leia and all of them are stuck in a trash compacting thing. And a little robot sticks its head out.
I don't think it's a robot. It's like some sort of tentacle monster denizen thing.
Oh, I thought there was like a robot head that stuck its head.
No. That was definitely some sort of biological.
It's been a long time since I watched the original trilogy. I've only been watching the movie 9 on repeat because it is the best Star Wars.
My esteem of you has fallen dramatically.
I mean, what can beat whatever Death of the Sith or whatever the 9th one was called? Yeah.
I think I stopped watching on episode 6.
Yeah. Yeah, that was a good place to stop. Yeah. Okay, so that was a monster. I swear my memory is a robot.
% certain it was a
Let's say you have a large interstellar floating fortress.
Okay. So not only is this USVs, this is now USVs in space.
Well, someone else solves that problem. And they solve artificial gravity, and don't worry about it.
Oh, I was just thinking there's a bunch of not very scrupulous groups that go into the ocean and just dump waste material they're not allowed to dump anywhere else because it's international waters. So now, our generation, our kids' generation have to build machines to go out and fix this problem.
No. I'm thinking robots that navigate lakes of waste.
Exactly.
To do something.
It's called the ocean.
No. No, I'm thinking like in a landfill, there's some mucky part with a lot of liquid, and we're going through, what we could be doing? Business case here. There's a landfill somewhere in the UK where a guy threw out a hard drive that had a couple thousand Bitcoin on it.
Yep.
And he's been searching through the landfill for this hard drive. So we build a robot that wades through piles of trash so as to find lost hard drives of valuable things.
They made fun of this plot on your favorite show, Silicon Valley. where he's searching for a thumb drive.
I mean, I think that's what I'm talking about.
Yeah.
So like how I think if you're going to find a needle in a trash haystack, making it into liquid probably is easier than just moving through the solid matter.
Make it into liquid. Like
flooding it.
I mean, I feel like if you're trying to recover, especially something like a hard drive or an electronic thing, the less wet it is, the higher chances. Ideally, it's totally dry, and then you can take some time in the next century to find whatever you're looking for.
But is it still USV if it goes through solid?
Well, that's what I'm saying. So like, I don't know.
Okay. How about this? All right. Not as apocalyptic as your version, but so shipping container ships, have a big pile of shipping containers on top.
Yeah.
And on every trip, some number of these shipping containers fall off.
Which always surprises me because they're literally locked.
Yeah.
So how the heck are they falling off?
Well, what's interesting is as a part of putting your container on a container ship, you pay into an insurance policy where you have no idea if you're on top, if you're on bottom.
Yeah.
But everyone who has a container on that ship is covering the insurance for the couple that fall off.
Yeah.
And since it's international waters and there's no reporting, no one actually knows how many of these shipping containers have fallen off.
Yeah.
So some of these containers have potatoes.
Yeah.
And like, who cares? Some of these containers might have gold or fancy jewelry or whatever.
Or BMWs.
At the bottom of the ocean.
Yep.
In a non-sealed container.
Yep.
So we need to build USVs that can go find these containers and get the valuable things out of it. Salvage USVs.
All right.
Yeah.
There you go. Okay, so I think we talked about this in a previous episode, but localization underwater is hard.
Let's say we talked about that before. Let's say localization solved.
So we solve it basically by running a wire.
I think where we should narrow this in.
Yeah.
Searching, that's lame.
Yeah.
Like, it's finding a needle in a haystack. NBD, LLMs can solve it. We'll ask ChatGPT, hey, OpenAI, where are the shipping containers in the ocean?
I can just see myself typing the prompt right now. Pretend you are a shipping container that has fallen off a shipping boat.
So that's solved. We've solved localization.
Yeah.
Because it's not a problem. I think what we want to do is let's not say like we're in the Hadal zone of the ocean. Let's say we're somewhere reasonable, like 50 to 200 meters deep.
Okay.
Like, submarines go deeper, but we're only going 50 to 200 meters is a level problem. We're not going to the Titanic.
All right.
Focusing on areas, stormy areas that are near major ports.
Yeah. A gateway to the ocean, like Ocean Gate. Anyway, yes.
So that's the depth that we're going to. We know where the containers are, and now our USV has to go to the container, probably cut them open and find the valuable bits of mystery inside.
Yes.
I'm assuming we have no idea what's in each shipping container.
Yes. That's a fair assumption.
Yeah.
Because even if they had labels, they've probably been worn off by
years.
Ocean.
Yes. So we've dropped our USV. We're at 100 meters deep. I think a USV that works at 100 meters, not rocket science.
No.
Like not non-trivial, but like
doable.
Yes.
Yeah, especially if we have a guide wire, like we can find ourselves. Yeah.
Do you think there's a world where it can automatically cut the thing open, like find it and do the underwater arc cutting? Because like teleop is also lame.
So I think the benefit.
And if you need a teleoperator, you need a cable to the surface.
Yeah,
lame city.
No, it needs to. No cables. I agree. I think what you do is these containers.
I live a wireless life.
Are steel, some version of steel. So it's magnetic.
Okay.
So you put magnetic powered grapples on the thing, which aren't very hard to run. You grapple to the side of the container, and then you fire up an acetylene torch, or one of the torches might not be acetylene. One of the torches that don't need oxygen.
Yep.
And that will burn right through, like a hydrogen oxygen torch.
Were you imagining the things gripping to the side of the container
and just boring a hole? Yeah.
And then like reaching through that hole, or the whole thing is going through the hole?
The whole thing is going through the hole. Okay. Right. So like you
because I was unwilling to accept it just puts a hole and then peeks around inside.
No.
Too lame.
No, it has to drive right in.
Yep.
Right. So you find the container, it tries to find the door, but if it can't, it just uses any sign.
I actually would expect the door is probably one of the worst places to enter.
Because of all the extra material.
It's thicker metal.
Yeah, well,
like
and there's locks.
If you ever see any of those like stupid shipping container house kits,
it's
like, hey, it's theoretically a shipping container house. we've taken all the structural integrity of it away.
Yeah.
By cutting into the frame and cutting into the corners and the door. And now it's just sheets of metal that are ugly that you have a house out of that costs the same as a house.
Yeah.
Like the cheapest place to cut is probably the middle of the long wall.
Of the top or whatever. Yeah. Whatever side is upward facing.
Yes.
So all the goods are on the bottom.
Yeah.
So you don't also burn whatever you're trying to cut through. Yeah. Cut in there. You need some nice big floodlights.
Yep.
Some machine vision probably.
Because you'll have to light up everything because everything's going to be a shade of blue.
Super dark.
Yeah.
100, 200 meters down, you have very little light. So big floodlights.
I mean, there's a world where you actually might need multiple robots.
I mean, if you're cutting a hole, you're probably going to have really space for one. Shipping containers 20 or 40 feet. They're big. They're not that big.
Yeah, but like you might... If your robot's floodlights are going to be far enough away from your acetylene torch, and if your soft bits that grab stuff...
Nah, just... floodlights, you can make them pretty flat, right?
Okay.
Especially modern LEDs.
Okay.
You can cover the thing in bright white LEDs.
Okay.
And it'll just be a big glowing cylinder that travels around the ocean.
Okay.
So
we basically we have a floodlight. Yeah. We know that our target destination. As we approach it, we do some pretty straightforward like LiDAR return type of math. Say, here's what the shape looks like.
Yeah.
Here's the target. The target surface is the longer surface, closest facing,
to the top.
Yeah. Closest. So then we add in local frame a target to get there.
Yeah.
How do things change once we've magnetically attached ourselves to the shipping container?
So the reason we magnetically attach is just to be steady.
Nothing moves.
Right? Like everything underwater swirls around.
Yep.
So by making yourself locked to the frame of the shipping container, you can at least cut a hole that's more or less circular. Then once you've cut that hole, once you're inside the container, you're largely protected from any kind of underwater flows. So you can navigate a little bit more freely. You don't have to be as worried about remaining anchored.
Yeah. But you also don't know how much space is going to be in the container.
You don't. You have no idea, right?
So, I mean, this is, like, we've talked before, maybe on the show, maybe just offline, about frontier exploration.
Yeah.
Now, like, obviously, if we're going into a shipping container, we know it's maximum geometry.
Yeah.
It's no bigger than a shipping container on the inside.
Yeah.
But there could be no free space. There could be lots of free space.
Yep. Yeah. I mean, I think exploration here is not going to be too bad just because it is such a small space. Any reasonable LiDAR that would work underwater, or cameras even, will work 20 feet away or 40 feet away.
I mean, the hard thing is we'll have to be able to identify what's down there and what's valuable.
Yeah.
The best way of which we can do this is we can buy lots of valuable things, sink them to the bottom of the ocean.
And then do machine learning on that.
Or we could get $100 million to do that in sim.
Well, okay. I have a better idea.
Okay.
You ask an LLM to start generating adversarial training material on what something would look like underwater. And then you learn off of that and see how well that goes.
Yeah. So we get into the shipping container, and now we have to quickly get to a vibe of, is this valuable or not?
Yep.
And I'm assuming there's a world where this is partially funded by some do-gooder society that just wants less trash in the ocean, in which case we have to bring everything up.
Yeah.
We're not in that world.
No.
This is cold, hard cash. If it is pierced open barrels of cyanide that is immediately leaking, like, that is not our problem. To suck it, dolphins.
I mean, actually, you know what? You know what actually the literally best way to do this would be? Forget cutting a hole or any of that. It goes down with a mechanically driven spear, basically.
Okay.
And it sticks the side of the container hard enough to puncture through it and deploy grapples on the other side. And then just inflates a balloon. Like inflates a buoyancy
I think
device.
Floating the whole container up is lame.
But that's so much more fun.
But that's a lame robot.
No, can you imagine? No, I don't agree, because you could equip the robot with enough compressed air and enough flotation bags to lift like 50 containers.
Yeah,
like there wouldn't be a small robot.
That's lame.
No, Let me give you this picture.
Okay.
Let me give this picture. You are for some reason out in the middle of the ocean on your private Stefan yacht.
Yep, it exists
as you do. You see a little flag that says autonomous underwater operations, but you ignore it. And then 10 minutes later, a container just surfaces near you. And 20 minutes after that, another one.
Yeah, exactly. With like a dying octopus gasping for life.
It just like suddenly pops into being beside you. That's quite a surprise.
Yeah. So when you got excited about this thing on your automated thing, the automated thing on mine was humanoid robots for like cleaning up waste underwater.
Yeah.
Like, I want us to go into this container at the bottom of the ocean and pull out like the necklace from Titanic.
That's right.
Yeah.
Yeah, didn't she throw it overboard somewhere?
That's deploy robots.
Yeah.
If I saw it in a movie, it's got to be real life.
Well, yeah, absolutely. Go. It's worth like $20 million.
I think 750 million or 250 million.
Oh, okay. Never mind.
Is the canon.
All right. Well, there you go.
Yeah.
Go out and find the necklace. It's probably been
trawl the ocean for the necklace.
I mean, it was probably swallowed by a whale. So
kill all the whales.
No. Come on. We have to respect the Japanese tradition of research whaling vessels. This is purely for research about how delicious whale is. We have to continually research this every year. It's the only nation that does it.
Well, so we get to the container. I don't want to bring up the whole container. I think that's wasteful.
Of what? Air?
Yes. There's a limited resource. We'll run out of it. We need it to live.
Okay, I want Spaceballs.
I want to go into the container, find something valuable, pick it out, and bring it back.
All right. So this is now a cylindrical underwater robot.
Yep.
Goes down with its floodlights, attaches, drills a hole.
Yep.
And then opens an iris, and a humanoid swims out of the cylindrical robot into the container to now look around.
It could just be like arms come out of the robot and grab stuff from the container.
Yeah.
So in terms of what could be valuable in a container, let's say maybe there's like boxes that look obviously like jewelry. Maybe there are electronics are probably useless. After salt. Yeah. Car parts might have valuable base minerals.
Metals. Yeah. I don't think there's going to be a good ROI on practically anything we dredge up from the bottom of the ocean.
Well, actually, if you just ran a radar and you got anything that looked like heavy metal.
Yeah, but okay, assume you found a solid chunk of platinum. Mm-hmm. That's still going to be worth $20K.
Okay.
It's not worth the trip.
Well, it's a robot.
Yeah. Well,
and they're cool.
Yeah, I mean the robot's only worth probably $2 million, $500,000 plus. So
we only need 30 chunks of $20,000 worth of platinum.
Yeah, exactly. Break even. Yeah, you go chase down the container ship. But you know what? Where actually this might be valuable is automated shipwreck finding, because that you find a good Roman or medieval or whatever shipwreck, you will make back your money.
Yeah, but there's only so many of those. The more efficient you are at finding gold from a shipwreck, the faster that market is done.
Well, you better get to it. Invest today. Or you start
sinking more gold vessels.
That's true. You go into the insurance business.
Mm-hmm. All right, so we're spearfishing for containers at the bottom of the sea. What are we calling it? Container Spear 2000.
Nah.
Oh. Dead air. All right. Container Spear 2000 it is. It was a failure of imagination from the other side of the table.
Yeah, I was thinking of Docker, but couldn't get there from here.
Docker?
Something about containers and running stuff in containers. Anyway.
Let's move on to what we're talking about this week. So kind of two subjects that I think are fairly tightly related. First about hype versus reasonable robots, and then about kind of a broader problem of business acumen, business people in robotics. And to kind of touch on the first, and it's funny, I wrote a blog post and I got a funny response from someone who I like, but not to his credit, the funny response. Ilya and I have been seeing investment decisions on robotic startups that are kind of this startup is really cool in YC, and there's companies not in YC who pre-product, pre-anything raise $100 million. So this YC company will probably be able to go do that. And it's often things that look like humanoid robots. And a thing I've been trying to think about for a while is it often seems like there's two distinctly different types of robotics companies. Or I'm sure there's a number of types, but there's two that come to mind. There's these companies that kind of are reasonable, that make incremental progress, that have a technology that is buildable or within the bounds of what with some hard work could be built, have a business that needs that technology, and can do things like build a robot, raise some money, build a robot, get some market validation, raise some more money, start going to market, kind of scale like that, kind of closer to a real business. And then there's this whole other set of companies that also superficially are robotics companies, but mostly raise off of their ability to create hype. So I'm thinking Zoox, for example, is a great one. Basically, they pitched, magic robo-taxis in 2015. So I'm thinking Zoox. Zoox raised a whole bunch of money in the 2015, 2016 era, largely off of wouldn't robo-taxis that could do everything for everyone be cool? And
Sure, they would be.
Yeah. And if in this series of slippery slope arguments will be trillionaires. I think about some of the humanoid companies that we've talked about before, where they have lots of demos, but like very little published progress that like people who understand robotics have gotten a chance to even look at, let alone like feel around with. And like companies like this don't fundraise off of pure technical progress, don't fundraise off of pure market progress. They fundraise kind of mostly off of, hey, if this is big, wouldn't that be cool?
Yeah.
It's a somewhat unique thing in robotics or in frontier tech that is hard for people in this or other markets to really grasp as different. And I think part of that comes back around to...
Another one we talked about in the office is that certain company doing centrifuges to launch rockets.
Yeah.
Where like, sounds great until you do the math and you think like, oh, wait.
Yeah.
There's so many problems.
Yeah, I mean, like in frontier tech, there's these companies who can raise off of kind of like non-fundamentals.
Yeah.
And are just like entirely disconnected from it, with very few people ever asking the hard questions. And part of this comes back to like robotics is a weird market, and part of that weirdness comes out in the quality of business people in robotics.
Yeah, and the inverse of this is also, I think, robotics is still hard enough, just like much high tech or frontier tech, where your average engineer has to be better than your average like SaaS software guy.
Yeah.
Right? Like just by definition.
Yep.
And so on one side, your engineers tend to be more specialized, more difficult to hire, more special purpose.
Kind of better engineers.
Well, yeah, sure.
I mean,
right.
I think
more
like,
cutting edge, let's call it.
Like I like to say they have to be highly proficient in like 3 to 5 disciplines.
Yeah.
Whereas you can be a fellow engineer at a SaaS company and be good at front end.
Yeah, just be good at whatever, at HTML.
Yeah.
Right. I think it's kind of funny where there's really, really good engineering talent, but then a weird business case.
And I think in a lot of ways, this looks like what the internet industry looked like in the 90s. Like pre-microservices, back when everyone had to build everything from scratch, to launch an e-commerce website, you really had to be a good engineer.
Yeah.
Like you had to build everything. There wasn't Stack Overflow. You just had to be able to hack into the mainframe, as the stupid memes go. And like a lot of like society's understanding of software engineers is based on what it looked like in the 90s. And that's still true in robotics, but not in software land.
Yeah. Yeah. I mean, again, like for launching a big web store, like there's examples of the early web grocery stores where they had to develop content delivery networks before content delivery networks were a thing to actually get data fast enough and distribute enough to their customers. So not only did they have to run the website, they had to build the web services, they had to build the routing technologies, they had to build the content delivery network, go talk to Verizon and whoever to make sure they could co-locate their servers at their CDN endpoints. So and like these days, you don't do any of that.
And what I think this creates in robotics is you kind of end up with this, like, there's 2 common failure points that I think account for 90% of business people in robotics. There's roboticists who really want to be doing robotics work, but are doing business stuff because they don't trust business people. They don't whatever. The Silicon Valley has a culture where like, why do you need business people? Everyone should be able to code. So roboticists are doing, product work or sales work or whatever. Or on the other hand, they hire kind of the most shystery business people because they don't understand that they're being shystery.
Yeah. Yeah. It's funny because I'm trying to think of this more through the business lens of like, let's assume you're like somebody who's running on commission based on sales, right? Who doesn't know anything about robotics, then that's fine. But why would you pick to work with a robotics company? Because
it's cool.
Well, sure. But from the hard math of it, right? You're signing up for a high-risk venture with potentially low returns, especially if you're on commission. Like, good luck selling robot stuff.
That depends on if you understand it to be high risk and low returns. I mean, like, let's say let's say you were working. Let's say you got a job as a salesperson at Figure for big corporate sales.
That's the humanoid robot company.
Yep. So they have a bunch of marketing material about implementations or kickoffs or programs or deployments or some very carefully selected marketing word with major companies. So if you're a hotshot sales guy,
work with BMW.
Not just that, like, hey, I can go with a case study on BMW and I can go wave that sheaf around Toyota and Ford and GM and say, BMW is putting us in all of their factories doing all of their tasks, which it seems like a minor lie to the salesperson, because like they probably read the kickoff stuff about BMW and assumed it is robots that are deployed in some specific area of some factory.
Yeah.
But like saying some specific area of some factory, but they're fully deployed, they're working all the time, to we're doing everything in those factories is like an acceptable sales lie. If I can go promise this to every major automotive manufacturer at $1 million a robot or $100,000 a robot, these people employ 10,000 people in each factory.
Yeah.
They have hundreds of factories. I could go sell $300 million worth of robots. And, SaaS commissions get a 10% commission off of it. Like, that seems like a great job.
Nice. Yeah.
I mean, the problem is, like, the press release is a 25% lie.
Yeah.
The press release was based off what the customer saw, but the customer saw itself was a 25% lie. The salespeople going off of the press release are lying again another 25%. And pretty soon you barely have anything that is real.
Yeah, because the reality underneath all of it is 1 or 2 robots deployed in a very carefully selected test site.
And that's from a non-shyster salesperson.
Yeah.
Like, if they're willing to fully go shyster, like, things get a lot worse. Like, there's an Irish term I like a lot called spoofing. Not related to hacking. It's kind of like business bullshitting, where essentially to be successful in business, you have to be able to spoof. But if all you do is spoof, you're worthless.
Mm-hmm.
Like, you have to be able to give a talk where you wave your hands and you talk about how cool things are and blah, 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 without any real content in it. But if you never have any content, you're not worth much at all. Part of my like headcanon about how robotics, where this dysfunction comes from in robotics, is a lot of roboticists are kind of too busy building the robot. They get impressed with the initial spoof. And like, sure, this guy seems cool. He name dropped 14 people that were neat. Let's go let him sell some stuff. And 6 to 12 months later, nothing's happened, but there's beautiful arguments for why nothing's happened. And there's beautiful comments on the progress that has been made. And it all seems kind of weird and whatever, but like the robot's on fire. Like, there's a lot of problems going on with the robot. So it's just let's kick that down the road for another 6 months.
There's almost, and that might be part of it. I think there's the inverse problem we've seen too. Mm-hmm. One is that engineering teams in robotics want to work on robots and not on business applications.
Yep.
And then the other one is like, the business is in trouble and there's all sorts of sales problems, but like, let's not care about that. Let's build the next generation, which will be more efficient and which will work perfectly.
Yep.
Right. And I think, engineering has some blame here too.
Oh, yeah.
We talked to.
I mean, like that's an old classic failure case for engineers of building products without ever talking to anyone.
Exactly.
However, in SaaS lands, you can rarely get to Series A with that failure case.
Yeah.
Whereas in robotics, like you're rarely pre-Series D before you get confronted with reality.
Well, yeah, and
especially in hype robots.
$500 million later, right? Mm-hmm. Like, oh, you mean my humanoid, which takes a literal order of magnitude more time to do the thing than a human, doesn't work on an assembly line
and whose maintenance cost is higher than a skilled worker's wage.
Does not work on an assembly line where fractions of a second are worth tens of thousands of dollars.
Yeah.
Right?
Yep.
Like, surprise.
I recently talked to a major airline who said that every minute that they can do something faster is worth millions of dollars.
Oh, I'm sure of it.
Yep.
Yeah. Like from my background on the, some of the industrial use cases, like you're talking about floor managers who'd get upset at a half-second variance on delivery times. Like, that is big money, half a second. Yeah, so I get it. Concretely, we had one team we were talking with where we kind of did the usual polymath pitch of saying, we can do the basic boring autonomy stuff. You guys can do stuff that's unique to your clients, that's interesting.
UI, specific behaviors.
Insurance, like all the stuff that
weird perception stuff that no one else in the world cares about but except for you in your particular environment doing your particular thing.
Exactly. And kind of the response we got, which is funny, it just still rings in my head, was this kind of response of like, yeah, you're probably right, but the autonomy stuff is fun and interesting, so we want to do that stuff anyway.
Yeah.
Which is like, come on, engineers.
Like, that's oh, crap, this program is going to get killed in 6 to 18 months. Everyone's going to be poor as a result of it, and it's predictable at this very moment. Yeah. We had another thing where we were talking to some folks, And they really, 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 really wanted to focus on the economics of 5 to 10 years from now before they had any deployed systems.
Yeah. That's like the classic flaw of any engineering discipline is early over optimization.
Yeah.
Just like
that's the whole reason why the Paul Graham line is do things that don't scale.
Yeah, 100%.
Because like I think Ilya, you described it when we left that meeting as like these guys are rearranging the deck chairs on the Titanic.
Yeah. Yeah. They're like, this particular group was
they were years in.
Yeah.
They were optimizing for like they wanted to spend a lot of time talking about cost and model 5 years from now.
Yeah.
And they had yet to have a customer deployment.
Yeah.
Yeah.
Yeah. So that's always like, yes, I think.
And like to be fair, important. The rationale about the customer deployment could make sense on paper.
Absolutely.
I mean, I think that the thought process was, if we do these things and don't do those things, we get classified as this type of company with this type of multiple. Whereas if we're classified as that type of company with that type of multiple, we'll be worth more money.
And like, for sure. But the problem is the main killer of robotics companies is not being classified as the wrong multiple or paying 1.5 times as much as you should be paying for a service. It's just not actually getting a robot deployed. that's like
as we said before, the default for a robot is it doesn't work.
Is it's not moving. Yeah. There's some great, I'm trying to remember, I think it was called Bolt, a specialized kind of VC / hardware incubator that did a teardown series and videotaped a talk and teardown series of the early iRobot vacuum cleaners. Mm-hmm. And those things are awfully optimized, like just terrible, right? Like the early iRobots cost probably 3 to 4 times as much as they should.
Really?
And we're just, if you look at the circuit board.
Sorry, they cost much more than they sold them for, or?
No, I don't know those details, but like, I have no idea. They probably made money because they still survived. Yeah. So like, probably they made money somehow, but looking at the boards, they had so many components. Like the motherboard of this little robot vacuum cleaner had like, guessing here, 300 components, 400 components. It was off. And part of that was the time that they started designing it in the late 90s. Yeah. Like you had discrete logic for a bunch of stuff. But part of it was just also that they didn't over optimize early. They just wanted to get the robot out, make sure that it works. And then the good thing they did was every single time something failed, like the floor sensor would get dirty, they would study the bejesus out of the problem and fix it first.
Yeah.
And then later come back and cost optimize it.
Yeah.
Which is so much more reasonable, because how the hell are you supposed to cost optimize something that you don't even understand is a problem?
I think there's a lot of, in the rest of the tech world, getting launched is easy.
Yeah.
It's, hitting a button on your website and putting an announcement in Hacker News.
Yeah.
And I think like the world has forgotten just how hard getting a product into market is in robotics.
Yeah. I mean, concretely, we saw this wave of LLM-powered startups, and everybody was relying on ChatGPT or equivalents or open source equivalents. So the differentiator was not actually the model you're running. The differentiator was like, how efficiently can you use your credits and actually have a business case? Which, like, at that point, if that's your question,
that's great.
Optimize away.
Yeah.
Right? Spend all your time optimizing cents on the dollar of every single thing of your stack. But that's not where robots are today.
Yeah. Like robots are right now a sheer force of will to get a thing into the world that can kind of sort of do a job that is kind of sort of worth more than it costs to do with via robot.
Yeah.
And that like maybe you need your early customers to care more about the robots than the economics. And maybe you need people to be tolerant to like really crappy uptime. But like it is then force of will to do things like create testing space and get equipment delivered on time and track down your vendors who haven't shipped the stuff they said.
And get your customers to pay you.
Yeah.
Is a problem I never thought we'd have.
Yeah, like it's that level of stuff that is more of the challenge in robotics than like we need to make compute an order of magnitude cheaper, and let's optimize all of our localization algorithms to do so.
Yeah, I mean, I'd go so far as to kind of propose a rule here in that if you're optimizing something that cannot be easily made an order of magnitude cheaper, probably not worth your time.
Yeah.
Right? Like if you can go from $1,000 computer to $100 computer, and like by I mean takes you a week to do it, not several years to do it, totally worth your time.
Yeah.
if it takes you 3 weeks to go from $1,000 computer to a $500 computer, not worth your time. Like, that's not going to make or break. For the first 100 units that you ship, pay the extra $500 out of your company pocket. Literally do that.
I remember once at Starsky interviewed a CFO candidate whose main stuff he wanted to talk about, his main like CFO stuff, was being strategic in timing for releasing money to his payroll provider and optimizing healthcare benefits so as to stretch the company's bank account to give them an extra quarter worth of runway.
And that's beautiful.
There are companies where that is the difference.
Exactly. That is gorgeous.
If that's what you're doing in robotics, you're already dead.
Yeah, you're not getting there from here.
Because there's a world where your robot just stops moving for 2 months and it doesn't matter that you can make payroll. So I think like companies who focus on over optimization are a clear sign of bad business. I think either complete disengagement of engineering from business or the over engagement of engineering in business are probably the other two signs of like bad business stuff.
Yeah, I mean, coming back, I did a talk at RoboBusiness recently. It's on our YouTube channel. But one of the points I'd made was like, in today's day and age, funding wise, and there's exceptions, obviously, but funding wise, you have to make your business work before you even go for a Series A.
Yep.
Series B for sure.
Yep.
Series A more than likely.
Mm-hmm.
Even us going through this journey, we got asked, Series B type questions the first time we started looking for a Series A.
Yeah.
It's like, okay, well, what's your cash flow predictions on like profitability and like whatever?
Or not even that. Like, tell me right now how much more productive your robots are than people. Like, well,
in your use case,
we sell a technology, so that varies wildly based on customer.
Yeah, exactly. So like, if you're going to optimize for anything, optimize for that. Yeah. Optimize for how you can become a profitable business before you run out of money, before you need another venture round. And if you look through that lens, $1,000 or $500 computer instantly becomes irrelevant.
Yeah.
Like that, if your business lives or dies by that, you have not raised enough money or you're employing way too many people.
Yeah.
One of those two things.
Or more realistically, you're working on the wrong problem.
Yeah, you're 100% working on the wrong problem.
Like if you need a robot that is profitable, that can have cost inputs that are sub $10,000 and can return 10x on hardware, like you will inevitably be disrupted by China.
Yeah. That's the other thing is hardware. Your best case scenario in those cases is you're wildly successful and you get cloned a year later.
Yeah.
Right. And then you're right back to square one of, okay, now I got to spend a ton on R&D and keep ahead of the competition. So you're back on that treadmill again. So business and engineering, both are to blame, I suspect.
Yeah, I mean, I think like the under-involved engineers have business people completely run amok, saying all sorts of weird stuff and promising all sorts of weird stuff to end customers.
Not that you'd ever do that.
I think I'm very good.
No, you are.
I'm deeply proud of how much I do not do that, and probably it mostly hurts us that I don't lie to VCs and customers every day. Yeah. It probably is to the point of general negative. On the other side, I think there's an amusing phenomenon in robotics land where there's a number of world-class roboticists who don't do any robotics work.
As in?
Like, to not name names.
Yeah.
Say you are a really, really fantastic, well-regarded roboticist who writes great papers and or big open source contributions and whatever. VCs say, wow, you're brilliant and you think you can do this big, ambitious, cool thing. Here's $100 million. You no longer write code.
Yeah.
Or maybe you're down to an hour or two a day of writing code and thinking about architecture. Suddenly your job is spreadsheets and talking to people who don't understand robotics.
But I mean, I think that's the essence of running a business. Like, period. If you're a founder of anything, that happens, right?
I don't think so.
Okay.
I think like the innovation of dual track engineering organizations is that your best and often most highly compensated technical people can spend 50+% of their time doing actual work.
Sure. But totally. But I'm saying like, and most of the people listening probably are interested in this at some point. If you're going to start a business, almost certainly, I've never heard of a case where you're a technical co-founder.
Yeah.
You start a business that goes anywhere, gets any reasonable amount of funding, and you remain doing more than 80% technical work. Like that is a fantasy.
So I think the percentage, we can argue percentage between 80 and whatever.
Yeah.
My point is, if I was the best engineer at Polymath, I would no longer be the best engineer at Polymath. My schedule right now is roughly 30 to 40 hours a week of meetings, 10 to 15 hours a week of email follow-ups. Like if I had been writing code at any point, it would have long been commented out.
I mean, same for me, right? Like,
yes, yeah, but like you're still involved in architecture, you're still involved in actual technical stuff. My overall point is if you build an organization around, like, let's say the best roboticist in the world,
yeah,
and then you have them spend 60% of time doing what I do.
Yeah.
Like,
so you're talking specifically about a technical founder who steps into like CEO role or COO role.
And I think, like, to list out companies, every unicorn self-driving car company is in that position.
Yeah. Okay. I see what you mean.
Like, to not name anyone specifically.
Yeah.
Every single one of those companies have a technical CEO who is, by some measures, or at some point was considered one of the best or preeminent engineers in their field.
Yeah.
Who has not been a significant engineer in years.
Yeah.
And like they can still keep up, and they still probably want to work on stuff, and they still whatever. But like they're mostly talking to like stupid VCs.
But to be fair, one of my
stupid stakeholders.
One of my golden rules has always been like always hire people smarter than yourself.
Yes,
right.
Totally. But like a lot of the hype companies, are hype companies
because of the technical whatever.
Because Brian Selesky is such a genius engineer that we should give him a bunch of money to be a genius engineer. And then live his life in spreadsheets.
Yeah. I see what you mean. I see what you mean. So
step 1, find best engineer in the world. Step 2, give them a lot of money to be a great engineer. Step 3, don't let them engineer.
Yeah, I think to boil down what you're saying, the kind of the Silicon Valley / technical innovation of dual track careers has not actually trickled down to VC funded startups yet. There isn't a clear case of like, I think we'll give you a bunch of money, but we need you to be in
hype robotics specifically.
Yeah.
There's been a massive disconnect in that area.
That also, again, to push back a little bit, that also might just be that's what happens when you give 2 people $100 million and need them to hire a staff of 30, 50, 100 people in the next 6 months.
More than that with $100 million.
Yeah, but you know what I mean.
$100 million, you're probably looking at spending that in 3 years. So you want to spend probably $40 million in the next year. So your staff is comfortably 200 to 400.
Yeah, exactly. Yeah. So I think it might just be more a symptom of like, at that point, your main job is recruiting and org structure. Yeah. It's not really actually technical leadership.
At which point, like if you made your investment decision off of give the best engineer a bunch of money to do the best engineering, you're self-defeating.
Yeah.
Like in some ways, you'd be better served by saying, let's find the best robotics recruiter, give them $200 million, and have them recruit a world-class team.
That's actually a good point. Like, how do you even fix that? I don't even know if there's a way.
I don't think you can give small organizations
that much money right off the bat.
I don't think it works.
Yeah.
Like, I mean, making this full circle, when I posted my blog post about hype robotics, which is available on our website, a guy who I like a lot, who's building a very real robotics company, and has been doing a lot of like good marketing videos. Like I get jealous because we don't do nearly enough marketing videos. Commented, well, what if you're a realistic robot and you're having hype? And my thought was like, dude, you're not a hype company then. Like, you have not raised $100 million pre-product. You're not in the running.
Yeah, you're already deploying stuff.
Yeah, like you're going to be judged more by how quickly those robots can do their task, and their cost versus productivity and things like that. You're not going to be,
which is the right metrics to be painfully obvious. Of what we're talking about.
I struggle to find multiple examples of hype robotics companies that ever become worth anything.
Yeah,
in terms of actual product deployed, like you could maybe say Waymo. At some point, you could say Cruise, but they're like partially out of service.
Yeah,
I just saw a weird Zoox vehicle the other day, so maybe, but like I'm pretty sure all those are still losing money organizations that are suffering at the whims of being able to be shut down.
I mean, yeah, Waymo's probably still losing money.
Almost definitely. Yeah.
If not day-to-day operationally, then for sure.
I'd assume day-to-day. I assume the depreciation on those vehicles
still outweighs their revenue. Yeah.
Everything else is worse.
Yeah.
And like I think the problem is that whole model just fundamentally doesn't work. And you like fundamentally like the lean startup idea of build the crappiest possible robot that is theoretically buildable and that someone might theoretically pay for and go from there is the only way that like a robot can happen.
A real business can get going.
But what's frustrating is that if you're going on that path and you see people raising $200 million for what is clearly fraud, it really bums you out, especially when your friends ask you, why haven't you raised $200 million?
Well, I mean, I really like what Michael Seibel told us. He was like, good. Let the dumb money go to dumb places. Like, that's just less competitors for you. Imagine $200 million going to a company that does actually actively compete with you.
Yeah, but
that's a much worse story.
As Alex Kolasich from 8VC called out in his recent like state of venture thing, in most markets, dumb money is good for smart money. Yeah. In venture, it's bad for smart money because it raises the prices on good deals.
Yeah, it raises the prices on everything. Yeah. Talent, good deals, vendors you work with, everything.
Yeah. So it doesn't quite work that way.
Yeah, ish, yeah.
And with that, I think we'll have to leave it to next time because I'm now 6 minutes late for a call.
Alrighty.
Going back to my 50 hours of meetings a week or 40 hours of meetings a week.
Yeah. I think you're honestly lowballing it.
Elliot, what are we talking about next week?
I don't know. Maybe it might be fun to do a polymath retrospective. There's been lots of stuff going on.
Retrospective?
Yeah. Something for the holidays.
That's a nice idea, yeah. A little Santa Claus retrospective.
Yeah.
Are we going to build our Santa sim?
No. No, we are not.
Elliot, shut that down publicly because I haven't asked about it privately in a while.
Yep. No, team's chugging along. They're busy.
Yeah, okay. I just want them to mush onto things that amuse me while making us money.
Yeah. All right, King Richard.
And with that, we'll see you all next time.
See you next time.